Hello everyone. In the last lecture, we have got an overview of ABAQUS modeling scheme. Now we'll learn about the modules one by one, hands-on. First, let's take a quick look at the interface. When you open ABAQUS, it looks like this. You can access the modules from the model tree, or from here at the top of the viewport. You can see the different modules here. We mentioned that we have these modules like Pert, property, assembly, step, load, mesh, job, visualization, etc. And from this sequence, you can kind of get an idea that first you have to make a part, then you have to assign property, you have to make an assembly, then you have to define the steps, you have to assign loads, you have to do the meshing, and you have to submit a job, and then you can do the post processing or visualization. So the first thing you do when opening ABAQUS, you set up the working directory. You can set up the like this. File set work directory. You can set up like this. You can create a bookmark. If it seems tedious, you can set a directory here so it will save some time. Then you start a model. It'll start what kind of model this is. And you can save as a KAE, a model database, in your directory. Right now it's set up at temp. I'm leaving it like this, but you can set up as you want. Now it will save tons of our time down the line if we familiarize ourselves with some conventions. So let's look at the conventions. Basically, in here, we'll cover three things. One is the interface, one is the conventions, and one is the Pert module. So we have just taken a quick look at the ABAQUS interface. Now let's get to the conventions. The first convention is units. It may seem a bit weird and a kind of different than the other simulation software because ABAQUS has no inherent units. It is the user's responsibility to be consistent while using the units. So let's say you are making a geometry with, let's say, a cube of 10, 10, 10 dimension. The ABAQUS will not set it by itself as a meter or millimeter or centimeter or something like that. You have to be consistent in your unit system. So if you draw a geometry 10, 10, 10, if you suppose that it's in meter, then you have to use these units for your other quantities. You cannot mix them up. So be careful about this convention. This is particularly important. The second one is coordinate. You can define alternate material directions based on Cartesian, cylindrical, etc. coordinates. Third is time. ABAQUS actually takes account of the time of the simulation and also the actual time. Time may not be relevant for static analysis or rate independent simulations, but it may be relevant when it comes to dynamic simulation or explicit simulation. And fourth is the degrees of freedom. It kind of uses different kind of notations for translations and rotations. So 1, 2, 3 means in X, Y, and Z directions respectively. And 4, 5, 6, 1, 2, 3 are translations, and 4, 5, 6 are rotations. So 1, 2, 3 directions means towards X, Y, and Z respectively. And convention 5, it's not a convention per se, but you have to deal with different types of files. Generally, when you try to create a model, it will be saved as a KAE file, and a .gnl or journal file will also be created. It will include the recorded data, and also there will be a replay file. You can also write after running your job, you can save everything as an input file so that you can share with somebody, and they will be able to just use the input file to regenerate in their machine, to regenerate that model in their machine. So these are kind of the popular extensions that come into play, and this kind of files are generated when you deal with ABAQUS. Now, next one is kind of a simulation checklist. At first, you come to the Pert module, you create a part or a geometry, and then you define the material property. The material property is not assigned directly to the part, rather you create a section that contains the part, and you assign the section. You assign the material property to the section. So basically, you create a part or a geometry, and then you go to the properties module. The material is actually in the property modules. There is no material modules. The material definition, you have to create it in the property modules. In the property module, you can see the part, and then you assign the material properties to the section. Let's say if you have a cube, you have different portions. You assign different material properties to the different portions, and those portions are actually those portions will be named different sections, and you have to make different section assignments so that the entire part will be covered by different material properties as per your need. And then you go to the assembly. Your geometry may or may not have more than one part, but regardless, you have to go to the assembly module and make an assembly. Let's say you just have one part, then your assembly will have just one part, one instance of a part actually. And then you go to these steps. You define the initial step is created for you, and then you create steps as per your need, and then you set up the relevant parameters there. And then you set up then you go to the load modules, and you set up the load predefined fields like temperatures and boundary conditions. Then you go to the mesh, do the meshing. Then you create a job with a model, with your model, and then you do the post-processing or visualization after the job is finished. So some of the terminologies may not seem very very clear cut at this moment, but if we go to the interface and create a simplified model, then it will start making sense overall. So now we have kind of a checklist, and we know what it takes to make a model to work. You don't have to memorize the sequence. It's kind of intuitive. Once you have completed making several models, it will become your second nature, and you'll probably won't miss anything. Now, creating a part. Let's say we're in the Pert module. See the sequence? We're the first module. We can also go through here. So when we're in the Pert module, we can create a part. We have to name the part. We have to define how will be the modeling space, whether it's 3D or 2D planar or exosymmetric. What type is it? Is it deformable? Is it analytical or Eulerian? And what is the base feature? Is it solid or shell or wire or point? And what kind of model are you going to be doing? Based on our selection, you can see that the options will be changing. Let's keep it in like that. We will make a cube, so it will be 3D modeling space, and it will be deformable. Definitely, it will be a solid shape base feature, and we will make a sketch and do an extrusion. Approximate size, let's keep it in 200. At this moment, we're not very concerned about the units. So let's continue. It's started the sketch, as you can see. How do we make a cube? We can just draw a rectangle and extrude it. So let's make rectangle, and we can set the dimensions. Let's say it's 20, and also this one is also 20. And let's say that we have a hole inside the cube. So we can select a circle. Let's say it's like this, and we will also define this. We can be as specific as we want. So this is kind of our basic feature, basic sketch. And after we finish, we click this, sketch this section for the solid extrusion. If let's say this sketching is done, we click done, and it's asking for the third dimension. We have the length, we have the width. We don't have the depth yet. We can set up the depth. Let's see, as it is a cube, it's equal. So depth will be 20. If it's okay, it will generate it. You can see that it has created a cube with a hole in the middle. So we can rotate it and save it and see it from different size. We can set different views. So it's pretty simple and intuitive. If we have to make any if we have to make any modification, we can go to the model tree. You can see that in the model, there's a part. And in the part one, there is a feature. What feature did we use? We have used the solid extrude. If we right click and edit, it will allow me to change the depth. What if we want to change the sketch? We just go deeper into the tree, section sketch, right click, edit. And you can see that there's an option for me to edit. We just delete the dimensions. We can edit the dimensions and everything. So if we just do done, okay, regenerate, as I haven't changed anything, the regenerate will not much make any difference. So that's how we do. But are there other methods? Yes. Sometimes you may have to use an orphaned mesh. Generally, we use a geometry or import a geometry, but sometimes we don't have a geometry. We have to start with an orphaned mesh. That is just a mesh, not a geometry. So we can create a geometry from the orphan mesh for our use. Also, if our existing geometry, let's say we have imported from somewhere else, probably from some other software, if it's faulty as per ABAQUS definition, there are repair tools. You can see that there are tons of options here, like extrusion, cut extrude, and if you like do a prolonged click, you can see the other options here. And also, like, you can you can edit the features, you can make partitions, you can do like other things like creating data mixes. Let's say if you want to do some operations in not on the surface but somewhere inside, you may have to create a datum plane, everything. And there are other tools available. We're just covering the ones that we will use most frequently, but time to time, some of the less used functions might be needed. We'll touch bases with them as needed. So in summary, what we have done, we have just learned three things. We have learned the ABAQUS interface, how it looks like, ABAQUS conventions that will come in handy, and created a Pert to learn how to create it and what methods are associated with it. So that completes our dealing with Pert module. Hope it's helpful. See you in the next lecture. Thanks.